Michael Jackson,
Yes.
COO of Adaptive Computing. HPC Evolution is a concept we've been tossing around, we've been talking here a little bit. What do you mean by HPC Evolution?
The HPC Evolution is trying to help organizations understand from a first generation environment to a very mature environment, what are kind of the steps that they will take, or what are some of the complexities that will get introduced to them. First generation is homogeneous. Next generation, you're dealing with applications that need different types of resources or heterogeneous environments. Next generation is really how do you break down those silos, bring it back together with dynamic or adaptive high-performance computing where you repurpose the environment to what you need it to be. And the final generation is where you're not just app optimized, but you are now trying to look at the end result of what your organization is trying to accomplish. You're applying workflows, you're applying other intelligence that helps you with the end-to-end process of getting that result that makes you money as an organization, helps you deliver on your mission, whatever it may be. So what it's doing is it's taking, the very beginning, people are homogeneous clusters, same type of hardware, nothing changed, apps had to have the same thing. And then people have begun to try to specialize their environment. That's what the app optimized. Mm-hmm. How do I get more memory for certain systems? How do I get GPUs for others? Yeah. And then the next, the final aspect is it's not just about the application, it's about what you're trying to accomplish with the application, the result. Okay. And so that's kind of the big picture, is how technology is advancing us from one single homogeneous platform to something that is delivering the results that we're trying to accomplish faster. In the beginning, everybody got create it yourself one type of resource that all applications had to consume.
Okay.
And whether or not your application needed more memory, it didn't matter. This is how much you got, because that's what you got, 64 or 256 nodes of the same type.
Okay.
And the big challenge up front was, if I have this homogeneous cluster, how do I take advantage of it? How do I share it? And so people started putting in the rules that allowed you to say, well, this department gets this much, that department gets that much. But if you complained about performance for your application, it was, you're just fortunate to have access to the resource. And as people began to say, well, that's not good enough, so some of the first things they would do is they'd buy a small little cluster that had high memory. Mm-hmm. And they basically created silos, fractured the resources. Another department says, I can't use your system because it doesn't meet my needs, and so I'm going to create my own little system. It's either got high network bandwidth or, and nowadays maybe adding in some GPUs. But then technology advanced with workload management, with Moab and other such technologies, to where, great, now we can actually get a heterogeneous system that has high memory in some of the nodes, has GPUs on others, has licenses that are locked to others, and your workload manager can understand that all. And it can take the workloads, put them into the right spots, and you get the highest application optimized environment. Okay. But even that begins to break down. Some of the new silos that people begin to have is multiple operating systems. So Windows comes in, they come in first at the desktop ends out not to be quite fast enough to do some of the simulation or the work that you do there. Mm-hmm. So they try to get their own little cluster, 5%, 10% of your environment. Yeah. Then you find out, well, this application works better on SUSE, this one works better on Red Hat, this one has only been certified for XYZ.
Yeah.
And you then begin to have sprawl and silos with the different OSs. We have some customers that came out with, like Cynet, they had about 8 different OSs. And a lot of it just because certain applications had only been certified up to a certain version of Red Hat. Mm-hmm. And while they also had others that were taking advantage of the newer versions of Red Hat, the old applications weren't there. So you start to have all of this fracturing again. And so there, the next evolution within HPC was, if rather than having a set environment for a certain application, can I make it changeable? Can I make it adaptable? Can I repurpose the environment to become what my applications need. And that's changing the OS dynamically, or it's changing security dynamically, or if other parts of smarts that you can put in there is energy efficiency that powers down underutilized resources, that has advantages at the beginning of the life cycle of a system when you're ramping it up. We had one customer paid for Moab in about 4 weeks just from energy savings. Then if you start to get to the middle of your life cycle, you're usually highly efficient, fully packed. There, you get customers getting 10, 15% efficiency savings of energy because you got it pretty stacked and there's not a lot to squeeze out of it. And then as it begins to wane and be older, as the new one's coming on, then once again you have a lot of opportunity to try to get the energy savings as you're trying to shift things over into the new cluster, and the older one you're still trying to stretch the life of it.
Is this a new thing that you're using as a way to describe your products? I mean, how would you talk about this HPC Evolution?
The HPC Evolution was just is a representation for people to help understand the maturity of high performance computing. And as people begin to try to aspire to how should their high performance computing experience be, what should it be like, this helps them kind of see if they're a first generation system, all they're going to deal with is a homogeneous environment typically. But if you understand that and you understand then I'm going to get disparity because of my different applications, then I might have multiple systems, then I might have to deal with multiple OSs, you can actually make sure you make a purchase of the technology that allows you to take that evolution and advance it. So one of our themes actually at International Supercomputing is about accelerating people's access to next generation high performance computing today. So you can either wait and learn and make all the mistakes early, or you can take advantage of the HPC Evolution type information, learn from what your best practices peers have done, and kind of get a leap ahead. And that's what we hope to help them out.